Good morning and welcome back to our trade show TV. I don't know if you had the same music in your ear when you started the live stream, because I just listened to I'm so excited. And I don't know how our people backstage do this all the time, that we have exactly perfect music if we open our live stream. So, welcome back, and today's a special day, because if it would have been the trade show week, the trade show would have been over. And I would be in the car with some colleagues driving home from Nuremberg, actually going home from Nuremberg to Ostwestfalen here to Ferl. Well, this year everything is different, and that's why we took the opportunity to invite you today to a trade show special. And the special is about our linear motion technology XTS and the new technology we presented already last days. And I would like to invite you to a tour around of very special exhibits we have and two experts, Rob and Jan are here, and we have a deep focus on our special new revolution for XTS. So, a special hot topic, something will remain similar as last time, and this is the way to get in touch with us. So please do me a favor, use again our chat functionality, write in comments, questions, whatever you have in your mind, and share your questions with us, and the expert team will follow up, will answer right away. You can also arrange a meeting. meet@beckhoff.com is the known email address. So just get in touch with us and ask whatever you want to ask us. Now, XTS special today means that with you, Rob, and then with Jan also, we tour around our exhibit here in Germany, and we would like to take a look to XTS in particular. But before we do that, I think we should start with the basics.
Yep.
So what is XTS all about? Because we use this now for almost 10 years, and I noticed it has developed. So what was the beginning and where are we today?
So yeah, we started small, or what we consider small now.
Yeah.
At the time it was huge, that we were going to have 3 meter circulating movers, 4 meters a second, 10G acceleration, 10 micrometer accuracy, and it's just gone from there. So we started out with the small basic mover, a rail on top. This still exists. This has been expanded now. All the basic concepts stay the same. So our feedback system, we've improved it over the years, but everything stays 100% compatible.
Okay.
I can take this module and put it into an 8-year-old system and it's going to work just fine. So we've got the standard setup with our rail on top for light loads. Then we've expanded. We went to a steel rail system. We work with, in this case, we partner with Hebco. And now we can put more 4 or 5 kilograms, something that 2012 would have been unheard of.
Well, that's heavy load already, 4 to 5 kilos, right?
It is,
Yes,
or it was.
Yeah.
Now we're up to 20.
We're 20 kilos
20
already
kilos.
on a mover.
So yeah,
Okay.
and we have a project now in China. They're putting 90 kilos on it.
So that's me.
They can transport me.
Oh,
yeah.
not both of us, but one of us.
Yeah,
Okay.
one.
So from the standard, we keep the system alive and similar, change just the dimension a little bit. So what do we have in the corner on the bottom there?
And then we went and said, okay, this is great, but what happens if I have food?
Yeah.
Right? And I need it to clean it. And I need it to not just be watertight. I need to make sure that there's no tight areas. I need enough spaces to get in there so that food, dirt, something can't stick and grow.
Okay, so the hygienic aspect.
The real hygienic aspect, not just, okay, it's stainless steel, away we go.
Okay.
We really went through the design to make sure it's truly hygienic.
And before you move up, you said we started with 3-4 meters, a couple or a dozen of movers. So what do we do today with the system?
160 meters, right?
Total rail, 160 meters.
160 meters,
Okay.
175 movers. That's going to continue to expand. So now that's like, we have multiple systems with 400 modules in it.
Wow.
50-meter systems are now commonplace.
Okay, and now the highlight on this trade show, the revolution, is a new buzzword. And Rob, you can tell us the buzzword, but you should not explain it. So what is the buzzword now?
The buzzword now is NCT.
Okay, and you don't tell anything, because I got Jan already. So you go over to the next station, and I will move on to Jan, and we would lift again the curtain of NCT. So what is NCT all about, Jan?
Yeah, NCT is, I would say, the logical improvement now of the system, because since the beginning, customers were dreaming to have action on the mover, have communication through the mover, get data from the mover, and that's what we now did.
Okay.
And
it sounds so simple to the mover. So how do we do this in particular?
And it should be simple for the customer.
Okay.
Of course, there was a lot of technique and development behind, but you can see it here, and it is really simple. We just improve or increase the size of the motor module a bit, so just a couple of millimeter, and that's it. And then we have the power and the communication fully integrated in this small bar we have here fixed to the module.
So it's more or less a standard motor module enhanced by the add-on for the NCT technology. And I can see this here on our little display, right?
Yes, we can see this here as an example, a station-based application where different action could be happen. For example, over there, a check of a product can be for a part which is okay or not okay. And yeah, this just as an example. But the good thing here is also that we have fully integrated this. So you see it here, that we can also mix it with our existing, and also even the old motor module, without any restriction.
Okay.
So yeah, that is really the benefit.
Tricky thing, if I would done it easy, I put a little battery in there, I have a little controller in each module, and I have a little program to control the LEDs, but this is not what we do here, right? This is more or less stupid because everything goes through our new module into the control.
Yeah, no battery, no cable, so
Okay.
NCT.
Yeah.
And even with the battery, our system's working 24/7, so of whole time you cannot operate. So that was very clear at the beginning. We have to go this way to have a wireless energy transfer to the mover and data as well, because without data, energy is nothing. When you cannot control and switch it.
So NCT is no cable technology. And then again, you said it's energy and data, which is both wireless, transmitted from the module to the mover.
Exactly. That's
Okay.
what we did.
We will have more details about this when we walk around. So let's take a look to the first application. And I will move around the corner. And Rob made his way to the next presentator already here. So I understand we can use the existing system by just an enhancement with a new motor module. I understand that we can integrate this also in existing units. We have energy and data on the mover without any cable. So now, what do we do with this function?
Pretty much
Pretty much.
anything.
Let's go. Let's go. What is
So
anything?
What we can start doing now is measuring the process as we're doing the process. So as I fill, as I change, as I actually make a product, I can measure the quality of the product while it's being prepared. So I can have perhaps that things like I'm putting a cap on it, right? And I want to measure how much pressure did I put on that cap. Right now we can put some feedback on the terminal itself and say, oh, hey, that cap was pressed, but there was no pressure on it. Oh, reject him. We don't have to have a secondary type of measurement. It's right in line in the process. So here we've got a setup with RS-232, so serial interface.
Yes.
Any serial device that I have, I can now directly put on the mover. So what we've done here is we've put up a micrometer to verify, right? I wanted to move to a specific position. Did I hit that individual micrometer? And we can see that, yeah, it comes back and confirms that we did. So if I need to adjust, so let's say things start to change, temperature changes, right? Maybe I can't control the temperature of my hull, so now I have to say, okay, let's make adjustments or let's make secondary measurements. The mover itself can make those measurements, report it back to the system and say, okay, we needed to go to this position, we made it.
So this is basically on-the-fly measurement.
On-the-fly measurement.
Okay, and fly really as
Really
it is,
means
on the fly,
On
right?
the fly, 4
Now-
meters a second, we can still do everything.
Wow. Now, RS-232 is, from my point of view, not the fastest communication, but we have fast communication. So what data rate can you achieve?
So
with
we
the
can
system?
talk to the mover 4,000 times a second.
Okay, 4,000. This is 250 microsecond cycle time.
Yes.
Wow.
From the PC to the module, from the module into the mover, 250 microseconds.
It's
Every 250
incredible
microseconds.
fast, and all the time in the closed loop.
Yep.
Wow. Now this is so fast, I think I would like to take a look to a second application, and Jan is already over there. So let's see what we have over here when we take a look to the next application, which we have prepared. Similar module, to
Yes.
make this clear, ladies and gentlemen, this is exact the same module all the time. We don't have specific modules or movers for different applications. It's always the same unit.
Yeah.
But now, what do we integrate here?
Yeah, we integrate, or we show here, first of all, we show here another use case of this new technology, really controlled loop. over an air gap. And what we did here is we have here an ultrasonic sensor, and this sensor is measuring the distance to this flag. And if we change this, the mover is following. But he's not connected, so there's not underneath a mechanical connection. So we really measure with the ultrasonic sensor. We transfer it via the air gap with our new NCT data communication to the module, via EtherCAT to the centralized IPC, and there the motion control calculate how the mover has to react, and there's the control loop, and then holding the distance always to a fixed value. And you see here, and for everybody who is known with control architecture, you really see what we have here at bandwidth with our very fast communication.
Now, this is already on Tuesday when we highlighted this for the first time. I really looked underneath. There is no mechanical fixture in between. So for my little IPC brain, it's really simple. So this is the ultrasonic sensor. It sends basically a beam. The beam is reflected, and the sensor identifies the distance.
Yes.
The information goes through the wireless communication with 4,000 cycles a second into the module, into the PC. We do the trinket calculation. It all comes back, and then we make the positioning.
And everything in 250 microseconds then. So
I got it right? I got it right, my
Yeah,
description? So I can join your department?
Yeah, absolutely.
Okay.
We have a table free for you all the time. But this is just an example. So here with the ultrasonic, but in real, it could be in an application also in force sensor. So if you have a certain action on the mover and have to control very well and very good a force to do a certain action there, that's what we can now do. Or another position sensor to measure something very exactly, we can do this now very fast and close whatever loop is needed to fulfill the application better.
And I understand in preparation for this show, you told me that these things are mostly done today with external units.
Yeah.
So all the technology was outside the moving part. Now we can integrate this, and this, it will save space and money and
and make it also faster, but because sometimes now you have to stop somewhere, do the action. Maybe if it comes worse, you even have to bring out the product again to some action, bring it back, and this, of course, lower the product weight of your machine. And now we can do it really on the fly and save a lot of time, and the machine throughput is much higher.
Wow. I think mechanically it's easy to understand. Let's take a look how it works on the software point of view. And for that, I will go over to Rob, and we take a look how we do this in terms of software, right?
Exactly.
Here we are. Now, before we do so, just quickly explain what this is all about, because I see a little white can. This is a Prosecco can. It's not a beer can. I'm sorry, Rob. For you as a Canadian, it should be a different can. But so what is the application? Let's start with that.
So this is actually something that we've tried over the years to implement without NCT. And it's really difficult. So what we're doing is we're actually orienting the product. So either we'll take a picture and say, hey, I want all of my cans lined up with specific angles of each beer can, so that's my label. To do that with belts and something that moves beside it is really, really difficult. But here, we simply take a picture of it, orient it how we want it, and then drive along. So one might go backwards 15 degrees, one goes forwards so much. We can then also synchronize to an external encoding system or external moving system. So if I really wanted to, I could actually place the label on the can as it goes by.
Okay, basically like a personalized can with my name. I think we see it right now.
Exactly. It's going to line up.
It matches the Beckhoff logo, right?
Exactly. So everything is brought back into TwinCat. We can coordinate that axis with the mover axis or any other external axis.
Okay, understood. So energy is on there. That's why we can rotate. Data is communicating fast into the PC and into TwinCat. But what is this now? Is this a very special function, new way of programming?
No.
No.
Right? It's the existing TwinCat. I don't want to learn anything new, right? I'm old. So what we did is basically it comes back into TwinCat. It's treated as a completely normal axis. It runs exactly like our stepper terminals. So anyone who's used those things in the past is going to find them very familiar. Or if you have a process that you've done one way and say, okay, now I want to change it to NCT, it's not a massive rewrite anymore. It's just, the motor happens to be here.
Okay, so NCT is the buzzword that we don't need a cable anymore. It describes so easy the benefit of everything, but everything else is standard as it was and as it is.
Yes, exactly. So we didn't, it makes life so much easier to
Okay.
not change.
Okay, don't take the can. Okay, I will be back. But I would like to move over to Jan again to a next example we have, which is, from my point of view, I think one of the most common ones,
Yeah.
because it's about grabbing parts and positioning parts. So again, let's start with the application, Jan.
Yeah, absolutely. So this is something which customer already using, but in the moment they use it with a fixed mechanical cam on the way, and then open the gripper while the mover go over this mechanical cam.
Okay.
But then you are fixed, because there's a mechanical cam, the gripper will open. Even if you don't want to open there, because you have a special part which you want to place somewhere else, you have no choice. And now people and customer get their choice. So we have here an example for a gripper with two stepper motors, and we control these two stepper motors with an electronic on the mover. And then one stepper is doing the linear movement, one is closing the gripper, and there, now you're flexible.
Okay.
With this, we come to a flexible system where you can do your action where you want.
I like to repeat this one more time. So we have the energy on the unit to operate the gripper.
Yeah.
We have the feedback system through also NCT into the control, and then we reward back opening and closing as well as positioning.
Yes, exactly. And on the software side in TwinCAD, it's just to another NC axis, like the mover axis is one, and can program it in the normal standard way. And this is just an example. Of course, you can also have a vacuum gripper later on this, because you even need communication and energy there, or could be a fast servo gripper or stuff like this. And if we think this further, it is a kind of robot system now on the mover, and a robot system which now can go with the mover around in the system. So it's not longer that you have a robot fixed in your machine at some place to do some action. Now, the robot can go around and do several action in your machine. And maybe a very good example for this we have over there.
Yeah,
in
but
the
I
next
got another
application.
question before we move there, Jan. I'm sorry.
I like to.
Because we forgot one important thing. I mean, these are two small, tiny motors from my point of
Yeah,
view.
they
And
are.
these are small little plates here. But in the beginning, Rob said that we have 20 kilos, 80 kilos, or even 90 kilo load on the XTS. So how much power do I have if I have bigger parts?
Yeah, so we have much more power than we show here with the
Okay.
two small stepper motors. We have 35 watt continuously, and even for peak. So if a servo gripper just have a small action time, we have 75 watt, and this is compared to a servo motor still a lot to really hold also heavy products safely.
Okay, start imagine what you can do with 35 watts on a gripper. And now, Jan, you are right. We'd like to take a look to our massive exhibit we have here. And there was Jan and Yannick and Hubertus and Matthias who were working on this over the last couple of days to get it done. And we would like to show it to you now in detail and in particular. So first of all, Rob, what do we see here and what is this?
So the plan here is to say, okay, what can we do with the XTS? Where can I use this NCT technology?
Right.
If I start putting things on the mover, what can it really do? So we say, okay, let's build a pick and place, because people have asked for pick for a long time, and now we can finally do it.
Yeah.
So we've got some movers set up with magnetic solenoids and little magnetic grippers. And the neat thing with the magnetic grippers is we call it a reverse permanent magnet.
Okay.
So, or a reverse electromagnet. It's always on, it's a permanent magnet, but to pick and place, then we actually energize it, and that allows us to drop the product.
Okay.
So in an event anything happens, we always have control of that product. We know where it is.
Okay, so we believe now there is concept material coming in any crazy order on the small black X-planar tiles, right?
Yep.
So how does the system identify those?
So first off, we pick it up with the camera. So we give the movers a shake to make sure everything's randomly distributed. Pick it up, come by with the camera, pick up and figure out exactly where on each of the X-planar movers the puck is. And then bring that puck in, and we coordinate the position of the X-planar mover with the XTS mover so that both line up at the exact right place at the right time for the mover to then make the pick. And then we basically energize the coil, say, go get the puck, and then drive around and go drop it off on the other side.
And as we use NCT, we don't need cabling or everything. It's all integrated into the system.
Exactly.
Okay, then it goes around like we do.
Yep.
So our material now is on the picker.
Exactly.
You go around the corner. Why do you flash here and again?
Exactly for that reason. We want to make sure that everything is empty before we place.
Okay.
So we want a specific placing pattern. So we say, okay, yeah, is everything there? No, something's there. Ignore it. Next one comes by, drop these three
here we go,
products.
yes.
So here, basically, it says, oh, hey, I can do a very quick, efficient place. 3 all at once. If I try to place in that small area with a delta, I need 1 gripper. Here we can have 3 individual.
Wow. You would need space, a lot of mechanical engineering with the grippers if you got a delta. So this is so much faster. How fast is it?
We're running about 2 picks per second.
Okay, well, if they were in suites, not bad, or any other mechanical parts. Now, here you release basically our magnet,
Yep.
put the parts in order, and then you shake it again. How stupid is that?
It was actually something I didn't think would work.
Okay.
So we give the little thing a shake because we need to slide them around. So we give it a quick shake or a spin,
Okay.
all right, and then come back under the camera so everything is randomly
Okay.
oriented.
Now I got it. Usually this is the order the customer needs. It goes into packaging, for example,
Exactly.
and that's
So here
done.
it comes out nicely formatted, all set for the next downstream product,
Okay.
right? And in this case, then we just want to give it a shake to re-randomize it.
All right. Well, what a cool example you and your team and Jan put together for the exhibition. And I think it perfectly describes actually a combination of different systems. So PC-based control, explainer for the base module, but then NCT as the core technology to get this all done.
And it's all the coordination, right? And it's simple,
Yeah.
right? That the coordinating the explainer movers and the XTS is no different than any other 2D or 3D axis system.
Wow. I think that's how I would like to close. It's so easy, like a typical normal system. Left is the camera, here's the camera. See, that's why I got a little earplug in all the time. So, Stefan, the 2 of us. So it's about how easy this system is. And this 25 minutes of XTS was all about that. NCT technology, the revolution of this trade show, can help you to improve your system, to simplify the setup, to simplify the mechanics, and to bring XTS to the next level. But based on all the things we know, it's the same trinket, it's the same philosophy, the same components, always just one new motor module, and that's it. Do me a favor, when you listen, start thinking about use cases in your application. If you need support, get in touch with us, with the global sales force, wherever you're listening right now, from the Far East to the West, from the North to the South. Use meet@beckhoff.com, or just get in touch with us here, which are working and presenting today. A pleasure for me to present you today the XTS special. Take care, all the best to you, and have fun with our new revolution. Thank you so much. Und das ist wirklich einer. So something really failed and the system identifies.